Good morning, good evening, good afternoon, YouTube. This is Tony, K4SDV, Kilo 4 Sierra Delta Victor, Kilo 4 Sheriff's Deputy, Vance County. Today we're going to, go over building a do-it-yourself Bandpass filter using a Bandpass filter PCB board that you can purchase from Tactical Radio Gear. Neat little board, makes the process very simple. It's a 3-pole Butterworth filter. It's not going to be a long video. I'm not going to go into a bunch of soldering stuff in front of the camera. That'll mostly be done off the camera, but we're going to touch some major points where some people seem to get, quite frankly, a little confused or maybe a little flustered. So what we're going to do from this step, I'm going to introduce you to the board. We're going to build a board, which is the easy part. The soldering and winding the toroids, absolutely, that's going to be the easy part. The hard part is actually easy. It's just a little confusing, so I'm going to break that down for you, and I'll show you how simple it is, and we'll be back in a second. Okay, let's cover some of the basics really quick. I started building these DIY Bandpass filters. Bandpass filters are expensive, so Tactical Radio Gear came up with a board. This is the board right here. This is the second generation of board. It's been refined. It looks really good. I built several filters from the first make of board. Now we're on a different make of board. Makes it really simple. You just plug everything where it's supposed to go. Quick and easy. These also now come as a kit for about $50 for any band you want to build. Don't worry, I will post a link to where to get the kit, or if you just want to buy just the bare bones board because you happen to have everything else you need. Another thing I did, I used 94 toroids. Now today we're building a filter for 15 meters. This has approximately 10 turns of 18 gauge magnet wire. I prefer B&Tech Go wire. I like their magnet wire. I like their silicone wire for portable lightweight antennas. Another thing we did was we pre-drilled their case. I like these SO239s better than the ones that you have to drill and then you have to screw in. These secure them with a lock nut, and of course they secure them with a lock nut on the inside here, and nice little dust covers. Keep dust out of our SO239. Another thing I did in advance, I pre-drilled these holes right here. This board is going to be suspended with a standoff, but it has to find ground to the case. So the board is grounded to the case along with your SO239s. Now I'm going to go ahead and say, when I start doing this, when I solder this up, one toroid is going to go here, one here, one here. Now I'm going to connect the toroid that goes here, here, and here, also here and here. Now if you want, and we're kind of getting a little bit ahead of ourselves here, so keep that in mind. You do not have to solder this connection here. You can actually go straight to your SO239. So this is going to go to your center conductor, the top on each side. However, I'm going to solder the toroid here, excuse me, and then bring a wire from the center conductor here and one here. But as I said, you can skip this part and go straight to the center conductor with the toroid. I'm not going to do that. I'm actually going to solder to the board and then connect in here. So bear with us, give us a minute, and we will come right back. Okay, at this point all our soldering is done. If you look at the bottom plate to my enclosure, I've zoomed in on it ever so slightly. I've made some standoffs, and they're really easy standoffs to make. They're M3 by 16 millimeter screws, 3 M3 nuts stacked on top of each other to complete our stack, so that it allows us to use a fourth nut to secure the board, because the board has to be grounded to the enclosure, and your completed board, when it's soldered, should look very much like this. Now I'm going to slowly rotate it. I want you to take note that all your turns to your toroids are facing upwards. Now I'm going to secure the board to the bottom of the enclosure, the bottom of the enclosure to the enclosure itself, and then I will solder on my center conductors, one to here, one to here. As I said before, you can skip this step and just solder this straight to your SO239. So these two you can solder straight to your SO239. However, I've elected to solder them to the board, and then the wires off of each center conductor here. Okay, now that your board should be assembled and mounted into your enclosure, you're ready to move on to the next step. Oh, by the way, I found these really great dust caps on Amazon. You get, I think you get 10, so 5 pair for $9.99. These SO239s you can get from DX Engineering. I think they're $5.99 each. I like these. I'm opposed to the other ones. I like these better because you drill one hole. You don't have to drill one hole, then 1, 2, 3, 4. Just one hole. They work great in the dust caps. Also, with this filter, this is an input or an output. This is an input or an output. Doesn't matter which side you use. What's important is the radio connects to one side. This coax goes to your external ATU if you want to use an external ATU, or to a resonant antenna. Do not use your radio's internal ATU in tune through the filter. You will blow the capacitors. Other than that, let's get on to tuning the filter. Hey, I know I said we'd be right back, but before we go, let's touch on the tuning real quick, because I'm going to have to set this down, zoom the camera in. I don't want you to be confused. But what you're going to do is you're going to scrunch your wires together. So on the 15 meter bandpass filter, we were looking for 0.86 microhenry. But once we get that 0.86, we crush our windings back in. Kind of defeats the purpose. So if you test one and it's where you want it, if it was 9 windings around the toroid, then it's going to be 9 windings around the toroid. You don't have to check every one because you're going to scrunch them up anyway. Another thing is, I like to use 6.6 Pacific for their calculator. For this particular filter, their calculator was 1, maybe 2 turns off, which means I could have used 1 or 2 turns less. So what I did was I went and I removed 1 turn. So for 15 meters, it said 10 turns on the toroid. I ended up having to go back, unsolder, take off a winding to make it 9 turns. I could have probably taken off another winding and made it 8 turns. But 9 turns, it works. So if you hook it up and you have like a really, really high SWR, like above 3 or above, well, 3 you can work with. Above 4, don't freak out. Come in, remove a winding off of each, solder them back in. Okay? All right. Good. Sorry for holding you guys up. I just thought you guys should know that. Be right back with you. Okay, we're back. I've hooked it up. I've turned on the Rig Expert. We're aiming for 15 meters here. So 21.225. It's going to be roughly, well, not roughly, but it's going to be the middle of our 15 meter band, because I want to use this across the whole band everywhere I can use it. So we're looking at a SWR of 2.27. So I'll set that down. I'll try to zoom in a little bit tighter. That's as much as it's going to let me zoom. Okay, 2.27. Alright. I'm not going to really be able to get this in here too much. Let's see, maybe if I do that, maybe if I scrunch that in like that, you kind of get an idea, a better idea of what I'm doing. I'm going to start with my center toroid that controls frequency. So I'm going to put finger nail on the very end winding, thumbnail on the other end winding, and I'm just going to spread them apart. And we should see our SWR start to drop. 1.18. Okay, now I'm going to just move that around a little bit. And 1.18, we're getting close to our frequency of resonance where we want to be. 1.18. Looks like that's as good as we're going to get there. Okay, so now I'm a military guy, former military guy, so I believe in starting left to right. However, we're going to start with this one right here on the right, and we're going to do the same thing. And we're just going to spread the winding apart. And just a little bit, and we're going to stop. 1.9, our SWR went up. Okay, let's move them back in closer together. 1.8. Okay, now I'm gonna go all the way over here to that fella, and we're gonna just spread the windings. I'm gonna go slow, just a little bit at a time, and I'm gonna stop. And we're gonna look and we're gonna see where we're at. 1.26. Okay, a little bit more, and I'm gonna stop. 1.08. 0.08. Touch her up maybe just a little bit more. I'm probably not going to be able to get all the way 1-to-1 with this without unsoldering them and taking off another winding. I knew I should have did 2 instead of 1, but you know, it's easier to take off than what it is to add it back on. And at 1.08, if I can get that back, man, I'll be satisfied. I'm not a greedy person. 1.08, 1.09. I am going to get a little bit greedier. Just a touch. Just a touch. Oh, come on. Come on. Let me love you. I just want to hold you, cuddle. Oh, man. Alright. So if you think you went a little bit too far, don't worry. Don't freak out. You can always just crush them back, squeeze them back in together. You did before. And I'm going to come over and mess with this one over here. 1.6. Alright, let's see if we can get what we get back out of this one. 0908. 0908. We get a little bit more. I think 1.08 is gonna be best I'm gonna be able to get. And you know what? I'm not gonna complain. And I really don't want to take this completely apart and take off another winding. I could, but I'm not, because I'm satisfied with that. Because I'm seeing 1.08 at 21.225, which is the middle of the band. So let's go down the band to 2100 flat. So if I were going to be at 21 point, I think it's 074 is where we're at for FT8. And let's see how she looks there. 1.04. So that's good. It's workable. Let's go all the way down to 0.03. Come up a little bit, it's 1.02. So now we're gonna go all the way to the end of the band, which is 450. But we're gonna make some stops along the way. We're gonna stop at, let's stop at around 150. So we're looking at 1.06. Let's crawl up the band. To 350. Let's see what it looks like at 350. I know we saw 1.11, but we're going to go with the 1.12. I like to go with the higher number as being the lower number. That little error on the side of caution kind of thing. Oh, we're at 473, we're at 1.16, so we're good. Low SW across the band with a resonant antenna. This is going to be, I'm sorry, 1.16, 1.15. But across the band, resonant, with a resonant antenna, this is going to be an awesome filter. Another thing about these filters is that if your antenna is not so resonant and you have to use a tuner, it kind of improves the SWR. Now, at what rate of loss, I'm not sure. To me, it really doesn't matter. I like to sometimes go out and do sideband with my 891 and then use one of my QDXs to do FT8 and FT4 and not have to worry about, not so much the QDX interfering with the 891, but the 891 wiping out the QDX and causing interference. And it allows me to work two things at once. And I have built several of these filters. The only bands I'm missing, I think, are 60, 80, and 160. And I'm going to build one for 160, even though I don't use 160, but just so that I have one for 160. And they work quite well. I'm very satisfied with every one I ever built. You have to remember, if you're building this, you're going to get out of it the effort that you put into this. If I wanted to get a one-to-one perfect SWR match, I could do that. But I'll have to take it apart and unsolder one side of each toroid, take off one winding, resolder it back. it's not worth it for me. I'm satisfied. I'm not that much of a perfectionist, but I do hope that those that are watching appreciate this short video, which I am dragging out by continuing to talk and run my mouth. But I hope you appreciate it, and I hope you build you some Bandpass filters and take your time and enjoy it and get out of it what you put into it. With that being said, I'm going to say friends, family, fellow ham radio operators. Also, I want to give a special thanks to my fellow veterans and also those that have served and those that will serve. Happy holidays. God bless. Be safe. Ham harder. Put on. Till our next video, try to just have fun. This is Tony, Kilo 4 Sierra Delta Victor, or Kilo 4 Sheriff's Deputy, Vance County, North Carolina, bidding you greetings and salutations and farewell. Good night, folks.